Hello everybody, welcome to November 4th and November 5th, because it is a daily double bonus episode here, because we're doing notes on both Wednesday and Thursday, so I'm putting them into one video for the ease of use, just so everything's in one spot. We're going to need to take two times because we're going to do some drawings today, and sometimes those drawings can take a little bit of time in class. Now, since you have the ability to pause this video whenever you want to make sure that you're getting the notes written down, feel free to use that feature. But we're going to talk about what we're doing on Wednesday with the notes. We're going to finish the notes, which will go into Thursday, and then at the end of this video, we'll talk about Thursday's assignment, which will be posted on Schoology in the Thursday folder. So first off, where you'll find all these things at is up on Schoology. If you go to Wednesday, you will see our bell ringer. There is a handout for the mitosis notes. There's a slides for the mitosis notes, which is what we're going to be going through. And then later on, we're going to be doing some drawings. If you want to see those drawings on your iPad, you click on the mitosis notes drawing, and it will pull up a thing that you can view the sets of drawings. It works very similarly to slides, except I have the ability to draw in them. So that's what's called a Jamboard by Google. But it lets me draw and stuff, so that's what we're going to do for our drawing portion for today. So the notes are kind of, there's not like our traditional like fill in the blank notes either, which is why it's going to take us a little bit longer to fit in there. So if you pull it open, you'll see that there's not too much to actually write down. So if you don't have a printer at home, you can easily just take these notes on just a piece of paper, because there's not too much to actually go off of as far as the actual writing stuff is going down. You're going to have to write them out pretty much equally either way that you look at it for it. So without further ado, let's jump into Wednesday and look at what we've got for mitosis notes here. I'm going to move myself down here so that you can actually see me here. And what we're dealing with mitosis is how cells divide up. So we're looking at how cells divide. First off, we have our words that start with chrome, which are all related to DNA. DNA will actually take multiple forms during this process, and this is just going through how DNA is going to work through some of those forms. They'll change shape. They'll be unpackaged or packaged depending on what we're having to deal with. So let's look at some of these chromes. The first one we have is what's called chromatin, with an N at the end of it. This is unpackaged DNA. The way that I like to think about it is that this is how our DNA usually is at when it's inside of the nucleus. So that N at the end, that chromatin, that N, stands for nucleus. So it's inside of the nucleus there. For that one, that's our chromatin. If you think about your traditional, how DNA looks, it's this weird curvy thing called a double helix. That is chromatin when it's in this double helix form. So whenever you see that, that's usually in the chromatin format that we're looking at it. Chromosomes is when they get packaged up. And this is important when it comes to cell division because we don't want our DNA damaged during the process of when our cells split. So we got to get them packaged up. Think like a suitcase. We got to have our suitcases all packed up, ready to go when we're going on a trip. So that's what the chromosome is. It is packaged up DNA. It's as a double rod. So I like to think about this one since there's some is usually at least two. If you got some of something, so that's double rods, two rods linked together. That is a chromosome. Usually it's as an X. So you got half of it being one rod, half of it being the other rod. So they're coming together. It's kind of making a little X shape. You can tell by this picture right over here. There you go. Wait, that one pointing right there, that X shape, I know it's sideways, but still an X, that is going to be a chromosome going on right there, some. And then finally, we got our sister chromatid, which is a single rod of that DNA. And one way that I like to think about this, we're splitting these in half from the chromosome. Split in half is two sisters. So the half of this, when they divide, D there, is the chromatid. So D stands for divide in this case. We're dividing them up, whereas in the other one, they're just resting in the nucleus. So we got chromatin in the nucleus. Chromosomes, there's two of them, so it's a double rod. Sisters are chromatid. That means they're split. They are divided So there's a single rod going on with them. And you'll see DNA change forms as we start going through the different steps. Now, there's a lot of C words that go on with mitosis. I don't know why they have them like this, but they do, and we kind of just have to live with it here. I'm going to cover up my own face so that you can see some of the pictures as we go through there. But the first thing we have is what is called the centromere. It is the center of the chromosome that connects up the two sisters. So think center, boom, right smack dab in the middle. We got the chromosome center right there. If we had a two-word definition for it. With this one, the centriole, it's an organelle we did not talk about. It's usually just occurring in animal cells. So we could have talked about it and could have just put it as an animal cell only one, but that would give us a lot of ones to deal with, and we already had a lot of organelles going on before. So we usually wait and talk about it specifically with mitosis. But we have the centriole. It basically just helps us divide. That is this weird little like noodle thing in the lower right-hand corner. You can see my mouse. Yeah, you can see my mouse. It's right there. Ooh, what if I do this pointer thing? Yeah, right there. This thing that I'm hovering over. That is the centriole. We then finally have cytokinesis, which this is a long definition for basically saying that the cytoplasm is going to be splitting in half. It happens at the end of mitosis when cells divide. It is where we get the pinching of the cell to happen to finally bloop, into two cells. So you can see here right next to me where it has the cytokinesis and it's pointing down with the arrow. When it does this pinching motion, that is cytokinesis, because cytokinesis literally translates into cytoplasm cutting. Because cyto refers to the cytoplasm, kinesis means to cut, so it is cytokinesis. So cytoplasm cutting in that aspect. And those are kind of our big vocabulary words of this kind of go around. Now we're going to go through is the different phases. And let's see, where am I going to put myself in this case? I might shrink myself down a little bit and put myself right up here. Let's go with that. So let's see where these things start off. Yay, an interphase. There we go. I'm kind of at the top here. We've got just a normal cell. So there's three things that we're going to look at for each phase. In interphase, the cell grows to mature size because this is our normal cell. So it just whoop, develops into an actual cell. We also get a copy of the DNA made. So we get two copies of the DNA because we're going to eventually split. So basically it makes one copy for itself, one copy for the new cell. And then we also prepare for division during this phase here. Now what we're going to do is make a nice little picture of this. So I am going to go to my toolbar here, my little kit. And this is interphase going first. So we've got a big old circle. That's going to be our circle in the middle. And then I'm going to make another circle in the middle there. That is going to be our nucleus. I'm going to put nucleus right there. Smack dab. We still have the cell membrane. Sure, why not? Cell membrane. We can label up there. But we don't have too much because, hey, there's a normal cell right there that we have. So this is going to be interphase. Let me put up interphase here. Interphase. Picture. Boom. Done. Seal it. Can I bold and underline that? Nope. Whoa, I think I just broke the internet there. Seeing into the frames. But there's interphase as our picture. I said you can freeze the video and go through it. Prophase. Now, for prophase, right after prophase, you can see right underneath of where I put prophase, I have in parentheses what happens. That is like the main thing to take away of what is going on with the phases. We'll have our three separate facts out on the other side. But if you want a quick thing of what is prophase, boom, that's what's going to happen. The nucleus is going to disappear. So in prophase, what we're going to have happening are these three things. We have the chromatin forms the chromosomes. We use this fancy word called condenses, but basically means it turns into chromosomes. It packages itself in there. The centrioles begin to move to opposite ends, and the nucleus is completely broken down. So let's look at that as far as a cell will end up going. I'm going to start a new picture here. Let me start out with the cell. I'm going to stretch it out just a little bit here. I'm going to take my, got my pen going. Let's use this one. We're going to have X's showing that the chromosomes are now there. They're no longer chromatin. I'm going to draw a dotted line around them. That is showing that the nucleus is broken up. And I'm going to use a different color here to represent these. These are going to be our little centrioles, and they're going to move to the opposite ends. So there we go with things here. I'm just going to label everything here. So we got prophase happening up top. These right here will be your centrioles, which is in red. Can I make this red too? Yes, I can. Ooh, I am liking this Jamboard thing. We can have the, let's do the nucleus breaks down here. And then we have just the plain old chromosomes smack dab in the middle. Chromosomes appear. Boom, right there. And there we have our prophase happening, where you have our different stuff happening with each one of our differences going on there. Let me make this a little bit of a blue there so you can kind of identify with the colors as well as the labels of what's happening. We'll probably have some colors happening in class as well. Since I like to color code things, we can color code things in class too. So if you want to color code, more power to you. If you got everything labeled and have arrows pointing to stuff, that would work too. So that is prophase. Okay, I don't know what was up with that. Metaphase. Everything is going to be taking place in the middle. So in metaphase, what is going to be happening is that the chromosomes line up directly in the middle of the cell. The centrioles shoot out these things called spindle fibers. And these spindle fibers kind of act as little fishing poles. So they kind of cast their net out. They're going to get a hook on. They're going to wheel them back. When they wheel them back, they're going to be pulling on the chromosomes. These centrioles are now officially at the opposite ends of each one of the sides there. When the centrioles shoot the spindle fibers out, they're going to attach to the chromosomes in the middle of them. So you can kind of see like a little picture of what metaphase will look like right here. Let's go ahead and draw one though. I'm going to get my circle back out there. Let me center it a little bit. Let me put up here, this will be metaphase happening. We're going to have a couple of different things happening. We're going to have our chromosomes lining up directly in the middle. Let's go with 5. The number of chromosomes, you might be wondering this, always depends on the type of creature that you are. For humans, we would have 46 of these lined up. Now, for obvious purposes, we're not going to draw all 46 of them out each time. Usually we end up somewhere with like 4 or 5 of them that we end up drawing, just because that makes it look nicer when we go to, color them up or whatever. I'm going to stick with red since I used red on my other ones. These would be our centrioles. They're now at the opposite ends. So centrioles, let me make that the red color. Boom, there we go. And then we're going to release some spindle fibers. Let's make those green. And they would connect up. I'm doing this with a mouse. So this is kind of hard to make sure that it connects right up to the middle there. But they're going to release these little fishing lines and connect up to the center of the chromosomes as best that they can. Remember that the center of the chromosomes is called the centromere. So they're going to attach up there. All right. We got the spindle fibers. Boom. Happening right there, connecting up to the centromere. And that's metaphase. You can pause the video if you need to see that stuff. Then we have anaphase, which is our 4th step. This is where the chromosomes actually physically split apart. So in anaphase, the centromere split. When the centromere split, that's holding the chromosome together. The chromosomes are now going to be pulled apart. When they're being pulled apart, all of a sudden they become the sister chromatids because they have just divided. So all of a sudden we have these sisters happening. The chromosomes are then, that should actually be changed here. I'm going to change it right now. to this because they are no longer chromosomes. These are the sister chromatids move to opposite ends. Boom, look at that, some self-editing there as we're doing it. Always making sure we get the highest quality of stuff happening. These sister chromatids technically are the ones moving to the opposite sides. So let's see what that looks like with our picture here. I'm going to get a stretched out circle for this one because I got to show them stretching it out a little bit. Let's go with Anaphase up top here. So that's what we're going to be dealing with. And I like to use these little C's or backward C's to represent the chromosome or the sister chromatids being pulled, because it's like they're being dragged apart. Like, no, I want to stay together, but no, they're being pulled apart. So they're splitting themselves that way. So let's get them labeled up here. Sister chromatids. Boom, on both sides happening right there. We have our other players just like normal. We've got our centrioles still on the opposite ends. So we'll add those in there. We'll label these up as well, centrioles. Boom. You just have to label one of them because if you label one, you probably have the other one labeled up. And then let's add our spindle fibers. Are still going in there. Boop. This one's a little bit easier to draw and connect it to the center. At least for me, it's working out a little bit easier. Hopefully for you, it's easier too. Boop. And then we'll do this part where we go spindle fibers in green. I'll try to find a good place to put that. There's our spindle fibers. And there's Anaphase. You got your sister chromatids being pulled apart by the centrioles to their other sides. They were once chromosomes, now they're being pulled apart. They divided. Remember, D, divided, the chromatids, with the D at the end. Splitting them up. All right, and then last but not least, we have what is called telophase. This is where we finally get two cells. So what happens with this one? We have the chromosomes coming to unpack again, and they're forming chromatin. So we go from the X-shaped back to the normal shape. We have two new nuclei form, each on their own separate halves. Cytokinesis happens, pinching it in the middle, separating it into two actual cells. Oh, I need to switch back to the picture to see what the picture is. So this one, I think I got to draw this one out, so I'm not going to be able to. So we got to get the nice little pinch happening in there. Pinch it. Boom. I'm going to draw an arrow going right there, and I'm going to put right smack dab here, cytokinesis happening. Boom. Pinching it in the middle. We're going to have two nuclei coming up here. Boom. Just like that. New nuclei. There's one happening there. And there's another one happening right over there. And really, that's all we need to really draw, because there's no X's because they've turned back into chromatin. There is, the centrioles would still be hanging around, but they're done. Their task is completed, so, I guess they would still be here, just kind of hanging about. But, for all intents and purposes, they are done with their duty. Okay, so hey, there's our notes over mitosis. Now, what you're going to do for your homework assignment, this would be on Thursday afternoon or night, whenever you're working on it. So let's go to the Thursday folder. Is going to be this thing that says assignment, mitosis phases. You're going to have a bunch of different pictures that you're going to take a look at, and you're going to tell me what phase that they are going to be in, which is going to be good because you just drew all of them for us. So it's going to show you 1, 2, 3, 4 phases here at this one. You just got to be like, oh yeah, that's metaphase, that's telophase, that's definitely a prophase going on there. And maybe that one's just interphase. And there are 5 sets of questions because it's row by row from a usual worksheet that we do, but we just made it online. So you usually have to look at this row by row, but instead we are taking it question by question. Is kind of a row by row situation. When you submit it, it should give you back the correct answers of what you got right or wrong, so you can always go back, look at what you got right, what you got wrong, figure out what the correct phase is going to be. Some of the phases appear more than others, because what this represents is if you were to look at your cells at any given moment, which ones would be happening right now. And there are some cells or some phases that happen more often than the others, just because how they appear. Like interphase is a normal cell. Most of your cells are just going to be normal for the most part. So they're not going to be actively dividing. So there might be a lot of interphases in this activity. That is okay, because it's mimicking how our cells actually will look inside of it. So that is the assignment. That is both Wednesday and Thursday's notes. Wednesday is there. Thursday is right there. Remember, once more, when you get on Schoology here, you'll have, you can have the printout of things. We'll show you on Wednesday. You have the printout if you want to print out the notes. You have these slides, which is what we just went over. This will have the drawings on there. Now know that if you look at these during the day, some parts may be missing. Just because I am doing this multiple times a day, and I will reset the drawings every hour. So if that is you, just be aware that you might not be able to see all of the drawings going on at once because of that. In fact, I might just make this one that I did. This is just for you guys that are doing this. This is for, we'll just put QL for quarantine learner right there. That is going to be your set of drawings, so you can always go to that one. Yeah, let's just save it. That way I don't have to, whenever you work on it, is however up to you. We'll make that call. I can make a separate one that I can have just for the ones that are in class. So look for that. Look for this video. I know it's been going on long, but hopefully you are following along. So really, by watching this 20-minute video, you have completed both Wednesday and Thursday, or maybe you just got the rest of the assignment to do on Thursday. That's my hope, at least, that you're able to follow along with it. So, but if you have any questions, do not hesitate to email me, and I will hopefully see you all back sooner rather than later. Bye.